Welcome back to Thrive, your go-to channel for transforming health, revolutionizing indoor air quality, and visionary environments. Don't forget to like, subscribe, and leave a comment down below to let us know your thoughts. Here's the first panel discussion from Thrive's Future Buildings Forum on energy and indoor air quality.
Excellent. Okay. Well, this is the part where you get grilled on your presentation. So,
bring it.
Okay. So we do have some questions from the chat, which I might start with because I think these come from Wendy, or these across everybody.
Yeah, across everyone.
Okay. There's a lot of questions. There's a lot of questions for Brock. I'll just start with the first one. So we see managing IAQ risk effectively as mission critical. Oh, hang on. Is this a question?
No, those, and I apologize for that. I thought the chat would strip away a lot of that formatting, but it didn't. Those are from me.
Yes, sorry. My mistake. I was just trying to read these off.
Yeah, sorry about the formatting confusion.
No problem. So the first question then is, what about reliable baseload source? Can renewables provide baseload source? Because this you said it.
Actually, what is baseload? Right? This is a concept that we have. Baseload that we need all the time. Now, if you're running your computer with batteries, it doesn't go to the base load, right? It goes to whenever. So I think that concept that the peak and base will change as soon as we are able to store electricity, right? Base and peak definition come to the electricity 101 was that electricity supply and demand has to be matched at the same time because electricity cannot be stored. So I think it's just a time of day use. So if you generate electricity with renewable, kilowatt hour is a kilowatt hour is a kilowatt hour. So once you store, it's everywhere. So I think the bottom line would be, what's the price of the kilowatt hour?
Yeah. The next question is, this is a question I have, how sustainable are batteries?
That's the question that you're writing is that you need a leap in battery technology in order to go to this vision that you have, right? And there's researchers all around the world working trying to make that leap, but without it, it's not a possibility.
I mean, yes and no, because you see, batteries used to be, when I took interest in electric vehicle almost a decade ago, batteries used to be $1,500 a kilowatt hour. Lithium right now cell level is $100 a kilowatt hour. But ultimate battery is gravity. Ultimate electricity storage is gravity. So it doesn't matter what form of storage comes in, will take over. I've seen, I think in Australia, there are remote areas that you take a train, you charge up, and then the gravity stores up. And in the electric car, if you're driving, you suddenly say, oh, I've got 20% battery. So suddenly, oh, I have 30% because you're up on a hill now in the ground because it converted back. So somehow somebody will bring in gravity. Maybe then the storage will be the cheapest. But right now, the technology-wise, I think what we have is pretty good enough compared to the alternatives. Burning fossil fuel, we are arguing about carbon capture and storage. These are all very expensive solutions. Yes, please.
But there is very different ways of storing energy. So for example, if you in peak production store and make something with it, as in whatever, have water basins and heat that up for transport when you have the power, as you said, gravity, you put water from one area up in a water tank up on the hill, and then when you need it, it's already in that form, or whatever. Snowy Hydro tried to do exactly that right now, where we produce things like that. So hopefully we can get away from a metal case where you put as the what I say old form of chemical storage into. I think we need to be more innovative. What else is there that we can do with the power to have it available to us later on?
I mean, chemical storage is doing okay. I mean, there was one company, I forgot the name of it, it's a British company. So they did a pilot in Africa. The concept is very simple. two people grab this about 10 kilowatt weight, 10 kilogram, lift it up and put into this, and just pull it, it comes down. Takes 2 hours to come down. As it's coming down, lighting up an LED. So you're converting that human energy into a sort of potential energy, and that kinetic energy is basically running those lights. That's again another story, right?
So we have to use less energy as well. Like, instead of a 10 kilowatt solar system on a house, but maybe it should only be 5, for example.
Sure, but again, the point is, how many cameras do you have in this room? We are not good at sort of maximizing as things get cheap, right?
And our more efficient equipment, cooktops and
There is, but the issue is, again, like the gentleman said earlier, that main criteria is cost, right? You said. Now, if it costs back, well, you care. You don't. Like, I had a situation many years ago when I first was experimenting with off-grid. I had in my apartment a few light bulbs and a fan running out of solar and battery. I was really excited. It was almost 15 years back. And one day I was switching it off, and somebody asked me, why did you switch it off? Well, that's a good point. It took me a while to process. Actually, why did I switch it off? Because the sun is free. My storage incremental cost is nothing. I said, oh, yeah, okay. On that day, actually, I changed positions on energy efficiency. Maybe long term, as things become free, you really don't care. Like if you're sitting next to a water reservoir, you really don't capture the bottle of, we have to keep the water because you have plenty where it came from, right? And nature has plenty of.
We might get differing opinions on this one. I'm not sure anything is truly free. Can I ask
Is
people?
your WhatsApp free? WhatsApp call free?
No.
Okay, good.
Is it?
No, I'm asking.
I don't think anything is free for sure. But can I ask that people that are asking a question, could you just introduce yourself so then we'll get to know each other?
Yeah, I'm Sheree. I'm from New Zealand. I work for Remote. It's one of the partners at Thrive, as well as the University of Auckland. Thanks for your talk, Sahel. I was, like you said, you're going to push people's buttons on this one. I wanted to talk about the notion that we would get off of fossil fuels from the perspective of developing nations, because it's all well and good to say that the Western world can do this, but developing nations don't have access to technologies in the same time frame that we do. And so I just wondered what you thought about that, because I don't know, like we don't translate our technology to developing nations at the rate that you would need to in order to get down off of fossil fuels there.
Maybe just before you answer, maybe a short answer, because we do want to keep it on the context of ventilation and indoor air quality, but go ahead.
Yeah, I mean, quickly, what happens, the per capita consumption in developing countries is much less. In Australia, it's a 15 kilowatt hour a day. If you go to remote Africa, maybe a couple of kilowatt hour a day, but everyone has the same sun. And solar somehow, thanks to China and thanks to early adopters like Spain and Germany, it's cheap. And this type of technology is no rocket science. So I don't think that's an issue, big issue.
Okay,
Or residential.
I'll put another another perspective on that.
Sure.
And it was prompted by Brock's air washers. So 1904, Carrier invented the air washer and installed it in and was installed there. It wasn't until 1950 that air conditioning, refrigeration, fridge cycle became commercially available, and that was the big boom in air conditioned buildings and the way we actually started to treat the buildings that we were working in. So let's rewind a step. Go and look at any building that was built pre-war. The architect should be saying this, not me. And what you'll notice is the buildings themselves have a very different form. If you go and walk down Collins Street in Victoria and look at the old facades there that have been heritage listed, what you'll see is the windows are narrow, but they're very tall. The reason they're very tall is that you could get some decent amount of cross ventilation going. Also, tall and narrow with a big high wall space means you could get light to the back of the room without having to have electric lighting all the time. So we kind of lost the skills in designing buildings that are suitable for the climate in which we're living. what is in Egypt ventilate themselves beautifully without any power, because they're designed to do that. And so if you look at the way the indigenous people build their buildings they're indigenous where they are, those buildings themselves tend to be very energy efficient. They tend to be climate efficient, and that's probably actually the way we need to phrase that. It's climate efficient design. Now, so it's perfectly feasible to design a building in Victoria, Adelaide, Brisbane, wherever, that is climate efficient, but it won't be cost efficient as the QS initially told the developer. So you've got to begin to look at all of that. But no, to answer your question, we've lost the skills. We've forgotten how to do it. If you went back to an 1890s Victorian architect, Victorian engineer, they'd roughly up a building in no time, but could actually maintain its condition reasonably well. They'd be big, they'd be heavy. Heavy is important because that gives you your thermal mass and thermal stability. And they'd have particular aspect ratios that got the energy requirement of the building down because it just wasn't available.
Can I contradict here?
Well, then.
I don't believe we've lost skills. I believe that the skills are very much there, but we're driven by responding to budget.
Yep.
You know, coming back to your presentation, and the building code, and I would say also a little bit of laziness. So we're looking for the quickest, easiest solution rather than stepping back and looking at a better, more holistic solution.
And that,
I believe the skills are still there, but we're motivated by the wrong.
yeah, that's it. Believe me, I opened door there. Because, again, just like the building cost is, or the building systems are driven by it, by the QS and the overall budget. The fees are driven by, well, it's a game of poker where the lowest hand wins. So, so you're asking people to design stuff for less and less and less and less. So people aren't going to put thought into it. They're just going to go, all right, what's the peak demand? Yep, chiller. What's the peak? What's my peak heating? Yep, that's the boiler. Next job, please. And that's
yeah. And unless you have an enlightened client, if I can put the onus on the client, who's willing to actually put the time and the effort and the dollars into doing something that's innovative and more responsible environmentally, it's you're just meeting a base metric all the time.
Or where you've got artifacts that need very careful maintaining.
Yeah.
Then you've got to look after them properly, and you've got to design it properly, and that's
the same for people.
Yeah.
And if we bring it back to Thrive research, we're actually starting to look into a project where we're going to be investigating what the drivers are. And I know you answered it in your presentation, but from the perspective of the full design team, so looking at it from the perspective of the architects and the consulting engineers, mainly obviously the mechanical engineers. And we're going to be doing some surveys across Australia to understand what are the drivers at the front end of actually selecting ventilation systems, and who makes those decisions, when are they made, and what's driving those decisions. So that's where we're busy putting that project together at the moment. And hopefully we will have some answers in terms of metrics towards the end of this year that we can share.
Lindy,
We've got lots of questions.
I think the mycologist here of anything that lives. Lindy, will you? Because what we find, what Simon said, you make the most amazing designs, and nobody looks that design is actually maintainable, and maintainable from the point of indoor air quality. So what we find is there is amazing air conditioning systems, and there is no drain, there is no hose. I mean, things they're absolutely basic to maintain and clean that system.
Well, I was in a meeting recently in San Francisco, organized by my colleague and friend, please, on this call, and we talked with a few people from large building companies. Now, the way one of them referred to architects that I know that the relation between architects and engineers is not very good.
So why it is like
That's why you're between us.
That's-
just we had this discussion at the forum in Melbourne. I remember architects, but the way it was put there in San Francisco that architects design something which has no reality to anything. I don't. Why is this a perception? Is this what?
No, he didn't.
So in this case, that's some fundamental issue: how to bring architects and building engineers together. And indoor air quality scientist, because as a consultant, to actually make sure that this then works and stays clean and is usable, because the whole thing goes down the minute if I can't maintain it, if I can't clean it. What do I do in a disaster? Because that is what we deal every day. Because all the energy consumption is great, but if I have no more power and all my chilled pipes starting to leak all at once, like it happened at Townsville, and then all my ceilings cave in, great, where are the engineers and architects and whatever? I don't care. The building doesn't work. Point. And that is what I would like to see addressed.
When you get a good design team and the architects and the engineering team gel, you get a great building. You always will. I've got probably in my career, I've designed 4 buildings where that happened. And they're all excellent buildings. But then you get
out of roughly how many? Out of roughly how many? A lot.
300 to 400. I don't know. But that's the problem. And that's the challenge.
Can I be a little bit optimistic around that to say that I think that a lot of the architecture that we're seeing that is what you described as high profile, that we're seeing in all the glossy magazines, that we're seeing in the James Bond movies, it's driven, a lot of it's driven by ego, and we refer to them as the architects, who are very much about the form of the building, and they're all about the next publication and the next award. And I'd like to think, optimistically, as not only a researcher in this space, but also as a teacher who's actually teaching architecture students, is that the next generation that we're coming through is a lot more mindful of environmental issues. And I think they very proudly brand themselves and their design, their ethical kind of perspective about that they bring to design around environmentalism and care for our planet. So I'd like to be optimistic to think that that might change in time, but maybe not quickly enough. But I do think that part of that is actually changing that narrative of an architect from the ego to being more responsible and caring more for the planet.
Well, I can tell you, I've just been waiting, but I'll just make a quick comment. There's 2 people. So as a teacher of engineers, you talked about the architects, then she'll change, but the engineers need to change. We don't teach engineers how to be creative. We teach them how to make things work. And that's a real problem. Maybe not all universities like that. I shouldn't speak for every university, but a lot of universities don't teach them to be creative. So the design courses aren't really good enough. And so there's always going to be, you're coming from a creative side to make something better. We're coming from a side just to make it work. And that's going to be
and be efficient.
Yeah. But just, and then, I don't know your name next to you, but just first.
Hi, Jeff Barberigama from Amazon Web Services. I look at the conversations that's unfolding here, and I sort of think what we're talking about, it's about the actors involved and the incentives that motivate them. Right? I think is one layer. The second layer is we're effectively talking about, I guess, in the way the lens I'll through is about climate change and what are 3 factors of climate change. So the gentleman in the middle is talking about how do you stop it, how do you slow it down in terms of the energy transition piece, but you can't do that in isolation. At the same time, you've got the comment that you really need to start looking at efficiency, right? Because it's going to take a long time for batteries to be rolled out in the extent that everyone hopes they will be. There's a lot of issues with batteries in terms of even how long they last, how good are they actually going to be long term in terms of climate. So you've got this piece around efficiency. We have to use less. I think in terms of all the engineers and architects and everywhere else, that's the challenge for now. And sorry, the last point in all of this is around adaptation, right? Because where we are is at a point where things have already changed. We are seeing more fires and more floods. And so trying to bring this back into clean air. It's then looking at what does that mean in the way that we live? What does it mean in terms of buildings that we live in, the environments that we're in, and what does that mean in terms of how do we manage those spaces?
Well, I agree with you. And if I put my health designer's lens on, we are already, we're not designing to mitigate climate change. We're not designing to reduce the impact of our buildings. We're actually designing to make sure our buildings can operate in a world that's different to this one. That's what I'm now doing. I'm being asked to design for higher rainfall intensity. I'm being asked to design for higher external ambience. I mean, in Victoria, we're designing systems now that are stable up to 50 degrees ambient in health. So, you know, in a lot of ways, yeah, we are definitely trying to mitigate what we're doing, but actually a lot of the designs I'm now involved in are accepting the horse is bolted, which is really sad.
Yeah, question for Simon. Gregor Rees from Era. Simon, you mentioned the NCC standards.
Yeah.
They've got standards, but there's nothing to say, please check. Would the NCC get the right vehicle to put those sort of mandatory requirements in? Like, if you were Minister for Health or who would be in charge of this, what levers would you pull to try to get something long-term enforced?
Great question. And really, as I said in the presentation, the standards that are there, the legislation that's there is all about making sure people do the minimum that they have to do. I don't know how you make people do the optimum.
Yes.
But other than but other than National Construction Code, ventilation codes like 1668, well, that's the standard. It's not even a code. Then there are very, very few tools.
You have drivers like neighbours, I guess, for energy efficiency.
But neighbours, it's voluntary, and that's but again, that's an energy efficiency mark. And although no, there is if you do Green Star, then you've got Green Star points for going up to 1.5 times the AS 1668 ventilation limit. Which is in itself is a bit of a game, because under 1668 you can reduce the 10 litres a second to 7.5 if you filter properly. So what people do is they filter properly, come down to 7.5, they go 1.5 times that, 14, and that's what they supply and get the Green Star point. So there are all these games that we play to minimise cost.
Okay, we have a question online, and there's one in the back.
Question on my from Ted.
Ted Bader.
Yep, it's Ted.
Ted's online. You want to unmute
hi,
Ted?
guys. Yeah, hi, Ted Bailey. Just wanted to say that in this world of rules and regulations and governments and decision makings, not everything is rational. And most of the people are just rational and assume that rational will prevail. At the moment, we do have some standards, and we struggle to even apply them. And I'll give you one example. When we moved to hotel quarantine during the pandemic, we simply shifted hospital facilities into hotels. That, in technical planning legal terms, converted those hotels into hospitals. No one sought to change the HVAC systems to ensure that they complied with the standards which prevail in hospitals. So arguably, and no permits were sought to do that. So arguably that shift was illegal, unlawful, let's just say unlawful. And 18 months later, certainly in Victoria, I can't vouch for the other states, the government's quietly conceded the point and did a review and changed the HVAC systems in those hotel quarantine locations. No one's ever been held to account for that. We haven't had a Royal Commission into the pandemic, and we should have. As the greatest interruption into our society in the last 40 years, at least perhaps longer. But that was a decision made perhaps with the noblest of intentions, despite the fact that standards existed but it was the wrong decision because it was made without consideration, without rational approaches. It was a wave of the hand out of a national cabinet meeting. We'll have hotel quarantine and that's it. And then everyone was to oblige, which is what happened. And from that, there was a significant toll. So we need to factor into the enormously worthwhile thinking that you guys are all doing, and it's very powerful, and it's great to see the advance into the research. We have to factor in the possibility that these things won't be applied, and we have to come up with a system to ensure they are applied.
Yeah, just jump into this conversation. I'm coming from a New Zealand context, and I was involved with Peter Gluckman in the science policy sphere that's occurring, and I'm not sure how it is in Australia, but perhaps something that Thrive could do is create an assembly of policymakers and air quality scientists, architects, and engineers to discuss the problem with people who are actually in the decision-making sphere, who have more knowledge of the inner workings of your government, and how they might bring air quality to the forefront of decision-making, especially in building codes. It'd be, I think, the only way to get that conversation off the ground.
I think that's a great suggestion. Very sorry about that.
It's already happening.
It's happening. Up the back.
Just first off, an observation. Matt Riley from the New South Wales Change, Energy, Environment, Water. Ted, interesting that you say about not making rational decisions. Every premier that I've worked with at the time tells me they're making very rational decisions. So thanks for your comment on that. But I wanted to come back to that discussion about regulations. I think one thing that we've lost sight of in the application of regulations, whether through its NCC or any other regulatory instrument you might want to point at, is what was the intent of the regulation and who's it for? And I'm interested in Ted, your view, Simon, your view on how people see NCC now. Every time I interact with discussions about the construction codes, I always get dragged towards the perspective of the builders, of the construction sector. The codes weren't written for the construction sector. Okay, they were written for us, the people, the community. And it's really interesting to know the comment about future.
Yep.
Yeah. How do the codes talk about the use of typical meteorological years to reflect 20 years? Well, 30 years in the future. This conversation has been around for the better part of a decade or more. Yep, a simple change. We still look backwards. Not because the community are asking for it, but the people who administer the codes, update the codes, almost all of the conversation about the codes are so heavily skewed towards self-interest that the intent of the codes is lost. So just interested about your thoughts on it.
I agree, and I think the problem with the NCC, and probably the biggest problem, the biggest factor in the NCC that leads to that deviation from it is the fact for most of the requirements you're allowed to do what's called a performance solution. So you can either go deemed to satisfy, or you can do a engineered performance solution, which is contractor speak for let's see how cheap we can get this. And so I think the introduction of the performance solution was the nail in the coffin of the NCC in that respect. So what they should probably really do is begin to roll that back, and the deemed to satisfy is the pathway, and you have to be much more rigorous if you are going to a performance-based solution, like you have to on the fire code, for example. You have to really demonstrate that if we're changing something on the fire engineering side, it is for the benefit of life safety. We should be doing then the same thing with the ventilation side of things in the NCC. And at the moment, because we've got this trade-off between ventilation and energy, or building performance and energy, there are lots of loopholes and wriggle room that we've got to play with when it comes to doing performance solutions. And I think that's probably one of the biggest issues.
Can I add to that the focus is also very much at practical completion of how a building is performing at that point. But there's not enough, and I think where we need to advocate is for that ongoing post-occupancy evaluation and monitoring and seeing how we're actually using buildings and that ongoing use. And I think there's a big vacuum there. So
yeah, I think there's a big gap, and we touched on that in design. There's a big gap between the building's performance as designed and as operated. Yeah, and yeah, again, yeah, if it's in certifying something as designed, skew the outcome towards the people that provide the solution, rather than skewing an outcome towards the people that the solution is supposed to be provided for.
I think Green Star noticed that in that you used to be able to do 5-star in design and then 5-star in construction. They got rid of that, and you can now only do 5-star in construction, because what they were finding is people were only going as far as the design bit. Then all these things would change in construction, and what was delivered was nowhere near what was actually designed. In the UK, the Building Regulations Part L, they introduced a fridge energy scheme thing, A to F rating, and you can have a big sticker on your building that's got what your building rates at. And there was a brilliant article, probably about 4 or 5 years ago, in the Sibsey Journal, just titled "Mind the Gap," and it was all about these buildings that were certified as A or B rated energy, and then they went back and looked at them in 4 or 5 years' time, and they were Fs and Es, because they just weren't performing as the designers said they would. But look it up and see Mind the Gap. It's a really well written article.
Yeah, it's a direct corollary with air pollution and BW and emissions. Yeah, you can just do a design and operation.
So neighbors should at least, or Green Star should at least put in a performance rating, which puts indoor air quality in as parameters, not just when it's designed.
Another point too is buildings are rarely commissioned.
Yeah.
So, how can you expect a model to say it's going to perform like that? How are you actually going to put that into operation?
Do you want to know why that
commission a building?
Do you want to know why that is?
Well, just swept under the carpet.
Cost. So for example, we commit to a building program. The building said, we're going to start building on 1st of January. We're going to finish it by the 30th of November, and things go wrong in February and March, and the building's a bit far behind when we get to April. But the deadline, the end date, the handover date's never changing, and that beautiful 6-week commissioning program that we had at the beginning of the job is 6 days.
Commissioning starts at design as well. So
yeah, we can have all that.
There is this traditional thinking that commissioning is at the end of the project. But modern commissioning now, similar to quality process, is all about starting as early as possible and with the view of how that building is going to operate, take it all the way through design, construction, and hand over into operation.
On the large projects, we have a commissioning review of the project as we go through, but that doesn't change the fact that when we get to the 22nd of November and handovers on the 30th, and that's what's left for commissioning, that's what happens.
Yeah, well, the construction industry hasn't adopted modern quality processes to their delivery. It's still like the 1980s. It's very much like how it was when I started. And it just hasn't changed, So,
doesn't that go back to what Matt was saying, that there's not the focus on the customer?
No, there's no.
It's opposite.
Where is the owner? Who is the owner?
Yeah.
No one sort of is thinking of that. Yeah.
Yeah, and you've also got that layer as well, which we haven't actually touched on that. Half the time, the people who are procuring the building aren't the people who are going to use it. And that makes a big difference. If you're designing a building for an owner occupier, they're much more interested in the outcome. Whereas if you're working and designing a building for a developer, really the cash is king. Deadline finished, hand it over. Let's move on to the next.
I've seen all the trouble in the residential industry here. Yeah, David, the chap. Yeah.
But just to extend on that, so at a practical completion, when a building is first occupied, we see a constant change and flux of who those occupants are over time, and technology is changing constantly. So the way we're using buildings, the way we're adapting to them is constantly changing. So in the same way that we are required to renew our driver's license every 5 or 10 years, aren't we required to renew our building operator's license and actually having buildings retested and measured? And maybe that's an area for advocacy.
Well, they change too over time. Fit outs and change of use, and all of that happens. And you could end up with a building that's non-compliant after 10 years of operation. Nobody knows.
This could have a completely different building occupancy 10 years after the build.
Yeah.
Yeah, Murshid from Department of Climate Change, Energy, Environment and Water, New South Wales. I think the topic is about indoor air quality and building design or architecture. So we move from Victorian style, where you have really all these a bit semi-confined spaces, to more modern, where it's open space and so on. And here we're talking about an industry of few $1 billion per year per budget. And they can say, we've done what we have and what we can, improving everything. And if we're talking about indoor air pollution, remember it's combination from different sources. It's not just because of our building. And you move into here reaction and management, okay, of the risk. But why would you don't go to the source and manage it as a source?
I chime in on that because we can't yet speciate some air pollutants to link them to a source. Like, for example, particulate matter, we're really good at counting how big are the particles and how many there are, but not what they are. And so I can't tell you where it came from because I don't know what it is, right? It needs a technology-linked measurement space in order to go, my indoor air has this particulate matter in it, and that's coming from that mine over there. They need to deal with their operational procedures to prevent the release of particulate matter, right? But we just don't have the measurements yet for it. And same for the continuous indoor monitoring of these unregulated but regulated contaminants. We don't have the measurement technologies for it. That's where I am in space.
We do.
You chemically speciate particulate matter.
Yeah, and I can talk to you a bit later about that.
Definitely.
Yeah. And the other thing is, if you want to be predictive, we have available now in our department our regional climate modeling, and will allow really to look at the future for 100 years or selected areas where most impact of climate change is going to happen. If you're going to have 30 days of over, say, 45 degrees C, how are we going to manage this with air conditioning at the moment? Okay, so big questions. I think we need to open mind and here start discussion about technology available and the science available to make a solution. At the moment, really, we're concentrating on one aspect of it, but we need to look at it on different situation.
I wanted to go back to Sharif as in source and occupants behavior, because when the building is built, and I know you all talk about high rise, but there's many in normal construction. So most of the buildings we get called to, they're already contaminated before they build. So they stand out in the weather, they go completely moldy because the framework is exposed. There could be bushfires putting subparticulates on it, and so on and so on. They have CRC treated timber as a chemical pollution. So while the building is built, it's already polluted. Then you have occupants moving in, and however they clean and whatever they spray, use in chemicals, in whatever occupants' behavior is in putting plants in their debris. So you constantly have new sources introduced, and a building ideally should be planned for to deal with all of that. Now that's wishful thinking, but we don't even monitor or measure or commission when the building is built. Is it actually source free? As in whatever my bugbear is, there's thousands and thousands of houses where the complete frame is already moldy to start with, or has other chemicals on it because now somebody tried to clean it or do stuff. Or when they go into air conditioning and they run it for 2 or 3 days, so that the first certified neighbor building was only within 4 weeks. They had 2 beams and they didn't quite knew then how to do it, and they were literally green, as in green from mold. And we just laughed, it was hilarious. And then I had to change things. So can we, or where would be the best point to actually look how is in the design phase, when it is ready, then when it starts to run, where are the pollution sources and how do we monitor, measure them? How do we say this is enough? So if you have more than X, then we might most likely get sick. And what do we do about it? And I think there is a lot of knowledge there that doesn't get implemented.
Definitely, but picking up on your point, I'm sure the architects, and correct me if I'm wrong, wouldn't have written in the spec, please install mouldy timber.
No, they write all building material.
That was down to, so that's nothing to do with the design of the building. That's nothing to do with how the building was intended.
I didn't blame you.
No, I'm not saying
We're both blaming the builder.
So you now, we've now said, okay, we've got the design right. How can we then get the build right? Which I think isn't part of what we're trying to talk about here. But that just shows how complicated a animal
but
we're actually playing.
Implementation of the building code. If it's specified all new building material and it should be dry and this and that, and reality is something completely different. And then we end up in the indoor air quality that schools and whatever office buildings are already pre-contaminated. And you just can't win anymore. And that's what we face as consultants out there every day. And that is, I think, one thing where Thrive really should pick up on and say, how do we ensure that what the end product is actually fit for purpose?
And not only at hand of a day.
Not exactly.
6 months, 12 months, 18 months down the line.
Can I clean the aircon? Is the building envelope in space cleanable?
Are there any parts of buildings or any aspects of buildings that are performance regulated? Well, they do check performance on.
Cooling towers.
Yeah, right. So it's only safety. Is it only safety issue?
Safety, explain it to see it's
just.
And the fire services.
Yeah, which is life saving.
Which is all safety.
Yeah. So those ones.
Life saving, something that you could prioritize up at life saving.
Yeah, not yet. The stairs, the threat of the stairs is more important than if it's completely moldy or completely whatever, full of whatever particulate.
Ventilation, other than, well, AS 1668, part 1 and part 3, fire and smoke, and fire and smoke, yes, on 1 and 3. So there are two parts of that standard that do nothing other than deal with life safety, and air quality is not part of that.
Not even the minimum ventilation rates. Much data. That should.
Well, this brings us back to performance standards. So we cannot resolve this issue just using building codes.
No.
Building codes, one issue, performance standards, like we have outdoors monitoring, it's essential. We will not be able to monitor all these pollutants because it's not realistic. Of course, in the research project, we can measure every potential pollutant, but that's not realistic. So that's why in the paper, we recommended only 3 pollutants because realistically, this can be monitored. And through these pollutants, in particular ventilation, some of the pollutants emitted by the sources will be taken care of. But source control, there's another issue. Because, again, outdoor, we have the standards, emission standards. So we should not bring to buildings, regardless of those issues of moldy stuff because of the problems with construction, but we should not bring products which emit, and this should be covered by emission standards. The issue with this is that inventiveness of the industry is such that one product is taken care of, another product is introduced. So this is continued pattern. But in this, there are two types of sources which cannot be controlled as humans. We cannot be controlled. We don't want to wear masks all the time. So it's one source.
And the second source is even if we take control of everything outside in terms of emission, bushfires remain. So this is also a source we need to control, and therefore buildings should be prepared for this source which cannot be controlled and for fires which.
Can I ask a question? Brock, is he around still? Everybody else. Hey, just purely out of interest, when you had the Canadian bushfires, how did the air washers perform?
It's interesting and a great question, one we've thought about, but we don't know how to answer it with numbers. Indoors in our building, nothing changed. We slammed all the outdoor air dampers closed when it started happening. But we know we were drawing outside air in any way because we have a number of exhaust fans that will instantly turn the building internal pressure negative relative to outside. But the air washers seen and in general historically have been very effective at deodorizing the air, taking whatever we could perceive out of in terms of this. I mean, it was a profound, frightening. It smelled like you were at a good barbecue restaurant everywhere you went in the District of Columbia for a week, and it was weird for us. But inside the building, no, and we attribute that to what the air washers do. And it actually it's got us thinking, well, wait a second, are we really making the right decision getting rid of these air washers? Maybe we have gotten very good at operating them efficiently, but there are design elements that make them uncompetitive with a more standard air handling design. But they did a great job, I think, during that event.
Because I've used air washers the other way around to remove smells from kitchen exhausts before discharging them into confined sort of alleyways and things.
Sure.
So they should have been really good at removing smoke.
We think they are. One of the problems we have is we can't put a number on it.
Yeah. Okay. Maybe we should think about bringing them back into design in Australia.
So don't get rid of them yet.
Yeah. And if you want to see, stop by. But it won't happen that quickly. And absolutely, during that event, one of the things we concluded was that air washers were very helpful.
Yeah.
Or at least for that 1 week.
Interesting.
And the big energy cost is cooling the water.
Well, no, that's you're cooling water anyway. Moving heat around, heat is heat. It moves from whatever medium to whatever other medium. What air washers have to have is a local pump to create that flux of fine chilled water droplets that you don't need that for other types of air handling. And that's the big irreducible cost.
So you've got pump energy on top of your fan energy, and that's where it compounds. Yeah.
Right.
Got it. Any more questions? Is there any questions in the chat?
There was some questions in the chat. If anyone wants to ask a question, you can please raise their hand in the chat so that.
Brock's got a few questions here that he's asked, and I'll pick one of them. One question was, what does 241 mean to the facilities team? For those of you who don't know, 241 is basically a guideline for pandemic mode operation for buildings. It was introduced by Australia, the American Society for Heating, Refrigeration and Air Conditioning Engineers. So it's basically guidance on what you would do if the next pandemic comes. How should we be ready for that? And Brock, I don't know if you had some thoughts on the answer, or have you talked with your colleagues about it?
Well, one thing is that it touched on the comment about moving folks to hotels, and would there, if in a magic world every building had considered this guidance as part of in design, would that have changed things? And more generally, there is the fundamental question for us is sometimes there's going to be a need to respond to an infectious agent threat. And sometimes there's going to be a need to respond to some external pollutant threat. And these things will probably always be in tension. And so how do we dynamically navigate those changing vectors of risk as best we can? How do we do that effectively? Because we have to do it ethically.
Where do you sit with your increase? So you're just running increased ventilation rates all the time?
Well, we intend to stop because we don't think we need to. But at the same time, we're also more effectively.
We lost you for a second there, Brock. Maybe just repeat the last little bit.
So we are planning to actually we are planning, as we were 5 years ago before the zombies came, to implement a version of demand controlled ventilation. We think we can do that safely, but we really would like, in the face of our experience over the last 5 years, to come up with ways to better understand exactly what the magnitude of our various risks are and how to use them to guide. We need to manage our mechanical systems dynamically. We know that. That's always been true. I think it's true for everybody. We just want to get better at it where we are, and we want to understand how to do that. What sensors do we need? What numbers do we assign to those sensors in terms of, okay, if this value exceeds this threshold, we do X, we take this action. We need to get that all written down so that the new guy knows what to do when it's his turn to work the third shift and something weird happens.
Can I just touch on 241? Because a lot of people are still quoting ASHRAE 241 and saying it means increasing ventilation rates. It doesn't. ASHRAE, there's a very clear procedure in 241 that says, first, you're going into pandemic mode. What is your pandemic occupancy? I.e., how many people are you having in this particular building? Based on that occupancy, what's your outside air? Does it meet that amount of air per person? And that's how it works, where everyone seems to have jumped on 241 initially and just said, oh, look, it's saying double the ventilation rate. It's not, it's saying half the number of people. It's actually what it's saying. And again, so I think people are latching onto 241 as a improvement for indoor air quality. No, it's not. It's actually a document to reduce the number of people in your building in a pandemic. And that by default reduces the risk because there's less people contaminated.
But it does allow increased ventilation rates in down remote.
Yes, per person. So if you've halved the number of people, you've doubled your ventilation rate without changing your air handling unit.
You're saying it doesn't insist that you increase ventilation.
No, but what it is saying, therefore, is if for some reason, say it's an emergency call center, and you can't reduce your number of people in your pandemic mode, then you have to increase your ventilation rate. Yeah. But everyone leapt on it from a commercial perspective, saying, got to change the airflow rate. No, we don't. I think you've got to think about it. Yeah, exactly.
Robert,
for us, for us here again, that my boss's boss hasn't read it. It's not gonna. We have to explain it to him, and we have to do that in under a minute.
Yeah, that's what's happened at Boeing. They got rid of the engineers. Thank you.
Sorry, Robin, I cut you off.
No worries. Robin Schofield from the University of Melbourne. A question for you, Brock. How does your system control and what range do you work with for the humidity? Obviously, that's going to be really important for the art, but it's also really important for infection control.
Sure, and a real.
Just a second part of that, what outside range of humidities do you have to deal with? What's temperature ranges? So the temperature outside, I guess you go from freezing right through to up to 40 degrees. Would that be
right? Yes, and forgive me, I'm going to use inch pound numbers because that's what we use here. I'm working on it. I'm working on it. I expect success, but I have not won the battle yet. So we are in Fahrenheit. Outdoor design condition in winter is 15 degrees, and outdoor relative humidity doesn't matter at that point. In the summer, I think it's 95 here in BC, and probably 60 or 65% relative humidity, which when you figure out how much water that is, that's a lot of water in the air. And that's the bigger challenge in terms of energy. It's the air washers traditionally have been, and this is true for museums globally forever up until not very long ago. 70 degrees Fahrenheit, 50% relative humidity everywhere all the time, no matter what. This is changing, and this is a great opportunity. It is also a great moment of anxiety, confusion, and uncertainty. Anybody know the word Bezo group, the Bezo Green Protocol? Kind of a bunch of art museums, fancy ones, mostly European. There's a couple of American museums that signed on early. We are presumably very publicly at some point, but we have embraced this movement. And one of the key things, it is a manifesto of actions that art museums can take. The biggest one is that they point out correctly that for most objects and most collections, the object doesn't care whether it's as long as it's between in Fahrenheit between 60 and 77 degrees and between 40 and 60% relative humidity. That's a big difference from 70, 50 everywhere all the time. And we are working now to figure out how to do that, because either you have to figure out a new dynamic set point for your systems if you continue to operate them the way that we always have, that is a pair of a temperature number and a humidity number. Otherwise, it becomes more, how do you keep them? Thank you for putting up this image of a psychrometric chart. We live and breathe the psychrometric chart, and that rhomboid that you put on there, that shape, that region, is where we're going with control. We need to keep all the dots, all the pairs of humidity and temperature inside that region, and we need to keep them moving gracefully. If they're moving too fast, we have to slow that down. Otherwise, we need to not put energy into whatever that dot is doing. And this is a very different kind of control problem to solve. This is different math for the controls team, and we're in the thick of it. We don't have the answer yet. That we've talked to other people who are doing it by dynamically coming up with a new set point, but we're not sure that's the best way to do it. We think more about trying to manage that region and just shepherd everything, all the galleries as they move around in that region. And we're working on it.
I see you running entropy control rather than set point temperature.
Well, so that's what air washers do. Air washers are Yeah, it's and but even you do all that with what you can measure, and you can measure dew point, you can measure temperature, you can measure relative humidity. So it's all in terms of programming the machine to behave. You come down from that high theoretical point to telling the valve whether to open or close.
No, just sorry. If you remember that psychometric chart that I put out, our blue thing, most control systems, like we have in this building here, is all they're doing is moving left and right, making the building warmer or making the building cooler. The challenge that Brock and his team face is they have to move left and right, but they also have to move not vertically up and down. It's up and down at a very slight angle.
And the curators care, the conservators care deeply about this stuff. So yes.
Yeah. So they're playing with two degrees of freedom, whereas most of the time in most buildings, what we call comfort cooling or comfort control, you're only looking at 1 degree of freedom. So yeah, they got a big challenge.
With that chart, it's interesting. Can we add a back and forth movement?
That's fine.
For example, that's fine. You know, silly, So with some trigger, some zones kind of red, like air quality, say CO2 levels might be indicator of occupants or something else, and the particles or rocks, those things, when hit some thresholds or outside of zone, it triggers some kind of change as well, together with humidity temperature.
Yeah, they're independent of the physics of what's going on between moisture and moisture and temperature, which is what the psychometric chart is doing. But yeah, I get where you're going, right? So you have a zone of control that's actually three-dimensional. That would be quite interesting. Yeah, don't know what it would look like, but it'd be quite good.
The other day, I was looking at the Berkeley Lab low-cost sensor research. So interesting. They're looking at sensors becoming that big, low-cost sensor can put in a device. I mean, a little sprinkler, fire alarm, put it in, alarm, and may do something worse. In the future, getting code, may want to go anything that's necessary.
But again, bear in mind, the sensor itself can be low cost. It's got a problem. So wire that sensor back to the BMS system so that you can then use that information, about $500 to $800 per point. So if you've got a sensor that's picking up, say 4 different parameters, $2,000 to get that information out of the BMS the other end. By the time the BMS have wrapped up all their markups and all the other stuff.
It's still long and streets. So what is that? Sorry, when you say the top driver is the dollars budget for choosing this ventilation system, what air quality, the quality air you breathe, where does this stand? Is it like a number 10 or number 20?
Currently, as a zero value.
Yeah. Okay. What is it for? What's the ventilation for?
Which was Jeff's point in his presentation, where he was saying, basically you can put a dollar value to that indoor air quality in schools, but currently there is no dollar value.
Sure. Hi, Graham from QED. I think I'd like to ask Brock, controlling the environment of the museum. This is all to protect not the people, but the actual stuff in the museum. Is that right?
Yeah. There's quite a bit of gallows humor at the National Gallery of Art from the facility staff about how the priority is the collection. And the decisions are made that lead us to ask, what are we, chopped liver? The collection, the job is in part to take care of the collection, but it is very true, and we have doubled down on our commitment. We are storytellers. We're here to share experiences, so our audience and our staff are very much priorities as well. And there's been some discussion in the comments about standards like WELL and LEED and the interest. I'm beginning to think that maybe this is. I'm not sure what you guys do in your neighborhood. In many neighborhoods that I've lived in, you go to a restaurant and there's going to be a little sticker with a letter on it. You know, is this joint clean? Am I safe buying lunch here? And I'm wondering if that's maybe something we could look at. And that would involve something. We practice continuous commissioning at our facility. We go back through and do the same thing that you do when you commission the building the first time and it's brand new. We take that list of functional performance line items and go through it every year for every system. We can account for that internally, but maybe some version of that could be applied to the expectations for public buildings generally. And made public.
Just to follow up on would be maybe a lot of research is coming out into localized solutions, local filtration, for example, that's heating, cooling, stuff like that. Could that be a solution for the museum to protect one for the pieces, the artifacts, paintings and stuff, in that, and the other people. So a centralized thing for people, and then all the pieces in a closed case. It's micro controlled.
Yep, that is very much, I think, the future of collection care is that for objects that really are so delicate that they can't be exposed to that fairly wide range of conditions that the Bizot protocol suggests. You are going to be building specialized controlled environments, local environments that are matched to the needs of a specific object or set of them. One thing that I wanted to whine and complain just for a second. It's very difficult for teams like ours to understand the language we use around these questions. Ventilation. Well, do you mean outside air, or do you mean recirculated clean air, or what exactly do you mean? Air changes is that clean air or outside air? We're fuzzy about it. It's gotten a little better, but it still drives me crazy because I don't always know what you mean.
Read our paper.
All right. So that was last comment, a question from Matt, and then we'll.
Yeah, it's a question to Brock. I'm interested that you only concerned with temperature and humidity, when surely the oxidative environment of the air impacts the collection. So, volatile organic compounds, ozone, nitrogen dioxide, these are all that can impact the collection. Now, it might be that they occur over a longer scale, but yeah, it struck me that the focus is just on temperature and humidity and not on the chemical atmospheric environment. Is that common that no one looks at that?
Well, no, we publish on that stuff. My immediate predecessor, as a member of the energy management team, was actually a real scientist and worked at before she came to us. Worked at Getty and published a book about the impact of various contaminants on various types of collections. We are constantly looking at that kind of stuff. We do a lot of hardcore science, but at the same time, what are you going to do about it?
Well, watch it when you get rid of your air washers because it'll change.
Sure. No, that is a big part of the conversation, and a big part. The conservators love them for a reason.
Yeah.
Yeah, our washers. They're working with the watch. That's
Right.
All right, I think we better stop because I'm hungry.